All right, so this will be a review for the test tomorrow on, what is that, March 3rd. So what I'll do is I'll go through problems that are similar to what's going to be on the test. Okay, so first thing you want to make sure you know how to do is work with the sum and difference identities for sine, cosine, and tangent. So you'll have some numerical problems that are, let's say, something like this. Okay, and the directions will say find an exact value. Okay, so first thing I have to do is figure out how I can rewrite 75. When you rewrite it, the two numbers you rewrite it with have to be multiples of what?
15, 13, no. 45, 30.
45 and 30, yep. So we have to rewrite 75, so it's written as multiples of 30 and 45. And you can choose if you want to do it as a sum or a difference. So what's the easiest way to write 75?
45.
Yeah, we can write it as a sum. And now this is a sine-sum identity. So we're going to look up, or if we haven't memorized, our identity for the sine and the sum, which is sine cosine plus cosine sine. So sine cosine plus cosine sine. And you fill in first, second, in that order in the parentheses. So first, second, second. Now, because these are all multiples of 30 and 45, they're all special answers. Okay, a lot of times they come out to 1/2, fractions with square roots of 3 or square root of 2. Okay, let's start with sine 45. 0.707, yep, is the square root of 2 over 2. Times cosine of 30. 0.866 is square root of 3 over 2. The cosine of 45, we just saw that number earlier, 0.707 again. So what's the cosine of 45? It's square root of 2 over 2. And the last one, sine of 30. Do you remember that one? That one comes out to 1/2. Okay, so simplify what you have here, and that's your answer. So when you multiply both what's on the left and on the right, what's your denominator? Yeah, it's 4. And square root of 2 times the square root of 3. Square root of 6. And k to the square root of 2 times 1. Just square root of 2. So that is the exact answer for sine 75. Okay, so I could ask you to do any angle here that's a multiple of 15. And it could say sine, cosine, or tangent. So, any questions on that kind of problem? Okay, the next one, let me give you something a little different. All right, so I want to write as either sine, cosine, or tangent. Okay, and I'm going to give you, let's see, cosine of 12 times cosine of 20 minus sine 12, sine 20. So this is kind of the reverse now. I already broke it down for you. I want you to tell me what this would have come from. Okay, so it's a cosine, cosine, sine, sine. That is a cosine identity. Yep. Is it a cosine sum or cosine difference? It is a cosine sum. Yes, when you have cosine, cosine, and then a minus, sine, sine, that is your cosine sum identity. What are the two things that you would sum together to get what I had there? Yeah, 12 and 20. It's just like working backwards. So this problem originally came from the cosine of what angle?
20 degrees. Wait,
32 degrees. And that's your answer. Right? So it's just the reverse. You're starting with something that was broken up, and you had to get it back to just a single term. In the last problem, we started with a single term, and we had to break it up. Okay, so any questions on that? All right, so let's, the next couple are going to be proofs. Okay, we're going to do, let's do them as a simplify. Let's say I do, and I could use sine, cosine, or tangent here. I'm just sticking with sine and cosine because those are the easiest ones. Let's do cosine of pi plus x. Yeah, it could be x, it could be theta. It doesn't really matter what that is. Okay, what kind of identity is this? It is a sum identity. Can you say which one it is again? Yeah, cosine sum. Yep. When I fill in my cosine sum identity, what's the first, my first angle? Pi. And my second angle? X. So I just have to look up the cosine sum identity, and it's what we just did on the other page. It's cosine, cosine, minus sine, sine. So cosine, cosine, minus sine, sine. Now, a lot of times when you have something like this, you're going to get a lot of zeros, ones, and negative ones. So let's see what happens. The cosine of pi, I could switch to radians, or what's pi in degrees? 90 would be pi over 2. 180. So we get negative 1, so let's cross that out, times cosine. And to do the sine of 180, we get 0. So I have 0 times, actually I'll just write it like this. So what I x'd out, I just substituted in two numbers for, because I calculated them. And what's negative 1 times cosine? Negative cosine minus, what's 0 times sine?
0.
So this actually just cancels out. So the whole thing simplifies to negative cosine. So two ways I could ask this question is I could say simplify, and that's what we just did, or I could say verify. If I say verify, I would give you what's on the left, right there, and then I would put equals, and I would put this on the right. So you would already know the answer. You would just have to show me these two steps. So simplify is actually harder than verify, because you don't know what you're supposed to get. But that is what you're supposed to get in this problem. All right, so there's a few of those. Let's see. Next kind of thing, looking at a problem like, let's say, yeah, let's look at this. If you had this problem, what kind of transformation is that when you do x plus pi? Yeah, it's a horizontal shift. So I might ask you what a graph of that would look like. I'd give you 4 different graphs to pick from. And you really just have to match it up by knowing it's the cosine. It's the cosine just shifted pi units, in this case to the left. All right, so you still have to know transformations for this test, especially when we do stuff like that inside. Okay, so there's going to be something similar to graphing. Also, let's see, solving equations. So basic equation would be something like, let's do 3 tangent 2x minus 4 equals 0. What would be your first step to solve that?
Simplify the tangent to. Or are we doing, it's not the quadratic.
That is not a quadratic.
So
Nope.
like we're not going to turn it into a tangent or something.
The only time you can do it is if usually you have like tangent squared. Sometimes you substitute in like an identity. But in this case, there's really no identity we're going to use because we don't have anything squared. And we don't have multiple trig functions. So we only have one trig function. So the goal is just get that function by itself. And then worry about the 2 after. So how would you get the trig function by itself? You would add the 4 and divide by 3. Now you can get rid of that function using inverse tangent. So we have the inverse tangent of 4/3, but that's not x, that's 2x. So yeah, divide by 2. So there's our answer. All right, the divide by 2, I'm not too concerned. We have to do that, but I want to look at the top first. You're looking for where tangent equals positive. Okay, where is that going to happen? Yep. So let's type in what we've got, and let's get our first answer. All right, so we've got second inverse tangent of 4/3. And then divide that answer by 2. Right, so we get 26.57, which we expected. That's in quadrant 1. And that's approximate. And what would be the, how would you get an answer in quadrant 3?
Is it 180?
That's quadrant 2. 180 plus. The other answer should be 206.57. And you can always check that by plugging it in and see if it works. Let's do it on the graphing calculator. Let's check 206.57. So we've got the tangent of 2 times, is it 206.57? Now it's not going to come out exact because we round it off. Let's just get rid of that. So that's that. Now we're going to triple it. And we get 4.001. And then the last step is to subtract 4. We got 0.001. We were supposed to get 0, but because of rounding, we didn't. Okay, so that answer worked. And you could go and check the other one, and it would work as well. So any questions on that?
What's the correct thing? Like, I forget which ones are in which, and I just want to make sure that those are.
So all the trig functions are positive in quadrant 1, just the sine in quadrant 2. Tangent's positive in quadrant 3, cosine in quadrant 4. And you need to know the formula 180 minus your reference angle in quadrant 2. We just did that one, 180 plus your reference angle. 360 minus your reference angle. Yep. Welcome. Okay, so you're going to have one like that, just a basic one. It's not a quadratic. Then we're going to have one that's quadratic. So let me see if I can try to make one up. Chances are, if I just make it up, it's not going to factor. Because what's that? Well, there might be one on the test like that too. There could be.
Give me anything that's possibly on the test. Just
All right, so let's try, because if you can solve with quadratic, you can use that to solve one that's factorable. Factoring is faster, but if you forget how to factor, you can always just use quadratic equation for everything. So I'll go over quadratic because you can use that for everything. Let's do 3 sine squared x. Let's do plus cosine x. It's really hard to make one up that doesn't come out imaginary because there's a lot of things that are going to happen here when I substitute. So I really need a negative for my constant, and that'll make things happen that are good. So let's try this. Okay, what's wrong with that? It's kind of a quadratic, but not really the way I would like it. It's not all the same trig function. So my hint was to always substitute for which one? The squared one. What's the identity that has sine squared in it? Pythagorean identity. Yep, sine squared plus cosine squared equals 1. So I'm going to leave everything else here. But I want to substitute in for sine squared. Okay, what is sine squared equal to? Yep, 1 minus cosine squared. And you know what, I'm going to make a change because I don't know if it's going to come out imaginary, but I think I can guarantee it won't if I make this a minus, let's pick a big enough number. Let's make it a minus 5. It doesn't change anything we've done so far, but I want to try to give you a problem you can actually solve.
The thing I'm really confused about is going from like the sine squared x to the 1 minus cosine squared x.
How we went from this to that?
Yes.
So if you solve this identity for cosine squared by doing this, that's gone. And you get sine squared equals 1 minus cosine squared. So you're just bringing it to the other side.
How do you know like which one you pick?
You always pick the one that's squared.
No, like what little equation you pick?
In this one?
Yeah.
Well, you pick the one that you have here. So if in your problem it's sine squared, you want to get sine squared by itself. If I wrote cosine squared here, you would have gotten cosine squared by itself. It's whichever one is in your problem.
Okay, yeah, I get that part, but like what are the Pythagorean identities? I don't know.
What are they?
Yeah.
Sine squared plus cosine squared equals 1. 1 plus tangent squared equals secant squared. And last one, I can always figure it out if I need to. Yeah, let's figure it out. So the way you can figure it out is that's if you know the basic one, divide everything by sine squared, and you get one of the ones I just told you. Divide everything by cosine squared, and you get the other one. So I gave you 1 plus tangent squared equals secant squared. And then so the last one, let's divide everything by cosine squared. Nope, let's divide everything by sine squared. So the last identity is 1 plus cotangent squared equals cosecant squared. So that's what's nice about the Pythagorean identities. If you don't remember them, which I did not remember that one off the top of my head, I can always figure it out. So there's 3. Okay. Does everyone have the Pythagorean identities now? Okay. Yep, you're welcome. All right, so now, what do we do with that 3? Distribute it. So 3 times negative cosine squared plus cosine. And now 3 times 1 gives me positive 3, take away 5. Negative 2. Okay, now we've got a quadratic that is the way we like it, something squared, and then the same something. They're both cosines. If I was going to factor this, I wouldn't want the negative in front of the 3. So I would divide everything by negative 1. But since I'm going to use quadratic formula to solve it, I don't care if there's a negative in front of the square term. That's fine.
Equal negative 5 or be negative 5. Like minus 5.
and then a plus 3. Because you have to do that.
So like, you had -5 up there, and you had -2 down.
Well, I had a -5, but I combined it with 3 times 1. Because 3 times 1 is 3, take away 5. So I combined like terms. Yeah. Yep.
I think it's going to come out. -4 times AC, it's minus 2 negatives multiplied together. So it's positive, so it's just
Well, let's see what happens. So what's A here?
negative
-3. And B?
1.
C? -2. So we got negative B plus or minus the square root of B squared. Oh, I think we're going to be okay. Minus, maybe, times 4.
Plus 23.
So
Negative 23.
yeah, so I have B squared minus 4 times A times C all over 2A. So I ended up with one too many negatives. So I could just change a number and make it work. So if we want to change it, we don't want to have all these negatives because that's going to make it imaginary. So the one on the test won't come out imaginary. So you won't have to worry about that. But what I could do is, let's, yeah, I probably had it fine to begin with. Let's make this a, make that a -1. I think that'll be okay. And now, 3 times 1 is 3. What's 3 take away 1? Positive 2. Right? So I tried to keep C the same, except now it's a positive 2. Any question on that? So I just changed that because I want the problem to work out nice, and it's really hard to make this up and have it work. All right, so now what's going to happen when you subtract a negative here? Subtract a negative.
It's going to be positive.
It's going to become a positive.
That's also nice too.
4 times 3 is 12 times 2.
24.
Wow, 24 plus 1
5.
is the square root of 25. So because it came out to a nice answer, this one is probably one you could have factored. But just keep going. What's the square root of 25? 5.
It's a negative 6 on the bottom.
So -1 plus or minus square root 5 over 6. And what's that equal to?
5.
Oh, thank you. Just 5. That's not equal to x. What are we solving for? We're solving for whatever is in the middle. Okay, cosine x. Okay. What's -1 plus 5? And what's 4 divided by 6, just as a fraction? 2/3. What's -1 minus 5? And what's -6 divided by 6? -1. All right, so it looks like we're going to get answers from both parts.
It's a negative.
Yes, -2. Good, those still going to get answers from both parts. How do we do the one on the left? Yeah, we just want to solve for x. Yeah, take the inverse cosine of -2/3. Second inverse cosine of -2/3, and we get 131.81. What quadrant is that in? That's quadrant 2. That's quadrant 2. So is that a reference angle? No, because it's bigger than 90. But to get that, if you're in quadrant 2, you do 180 minus your reference angle. This is the quadrant 2 answer. So we can figure out what the reference angle would be. So just subtract, basically just do 180 minus 131. That's your reference angle. So we got 180 minus 131.81. So my reference angle, which sometimes I get it automatically, this time I didn't, is that. So now, this is one answer. Where else is cosine equal to a negative besides quadrant 2? Quadrant 3, yes. So what do you do with your reference angle to get an answer in quadrant 3? Add it to 180. So 180 plus 48.19. So your other answer is 228.19. Okay, and those are the harder answers to get because they're going to come out messy. This one's going to come out nice. What do we do on each side to get x by itself in this equation?
Inverse cosine.
Yep, inverse cosine again. And the inverse cosine of -1 is 180. Okay, so this problem had 3 answers.
So if it's only on the axis, it's only that one answer.
Yes, because it's not in a quadrant, so that's different. So it really it can't get too much worse than that. That's the worst kind of problem you could have. Let's see. We went over one in class that was kind of like this one. Secant x equals cosecant x. What was the suggestion to do here on both sides? So usually you want to get it equal to 0, but that's not a quadratic, so you don't want to do that.
Wouldn't you like break it down as well like it used to be? So like cosine, like cosine of it used to be.
Yep, eventually we'll change things to sines and cosines. But divide by one of them. It doesn't matter which one. Anyone. Secant. So divide both sides by secant. What's on the left? 1 equals cosecant secant. And now let's do what Maggie just said. Change cosecant to sines and cosines. What is cosecant? Yep, 1 over sine. And what about secant? 1 over cosine. And if you do 1 over sine divided by 1 over cosine, what was that going to give me? That's cosine over sine. Right? When you divide two fractions, you take the one in the bottom, flip it, and then multiply. And now, what is 1 over, what's cosine divided by sine? Cotangent. And if we know the cotangent is equal to 1, what else is equal to 1? The tangent. And now you've got an equation you could solve just by taking the inverse tangent of each side. And as always, tangent's equal to positive. So you're looking for the 2 quadrants where tangent is positive. You should get an answer here and there. It's 45, yep. And what would be your quadrant 3 answer? $225. Yep. Okay, so that one's a little different, but that's how you solve it. Okay, and then the last part of the test is going to be what we did today. So I'll give you a problem. I could give you one of 3 types. What are the 3 types of problems we did? We didn't do side, angle, side. That'll be next time.
Angle, angle, side.
We did angle, angle, side. Side, side, angle. Yep. those are the three types that you use law of sines for. So this is the tricky one, where you could have 0, 1, or 2 solutions. But I'll let you guys pick which one of the three do you want to look at an example of.
Yeah.
Tricky one? All right. All right, so let's try this one. A is 6, B is 7, and beta is 30. How do you know this is a law of sines problem without making a sketch? Yeah, we have a row that's complete. And how do you know that it's the tricky case? Because you only have one angle. Right? You have a row that's empty, and you have no way to find anything in that row. So what am I forced to find first? Yeah, I got to find alpha first. So when I set up my law of sines to find alpha, how would that look? Okay.
Over 7.
Yep.
Sine over 6.
Okay, so now we have a proportion, and how do we solve that? Cross multiply. And really, I don't even need to cross multiply. You can just multiply both sides by 6. So you get 6 sine 30 over 7 equals sine alpha. Okay, and what's my last step to get alpha?
The inverse sine of 6 sine 30.
Take the inverse sine of what's on each side. And let's type that in and see what we get. So we got second inverse sine. 6 sine 30, make sure you close the parenthesis. Divided by 7. We get 25.377. Now, I have to check for the second answer. Okay. What do I do with that number to check for a second answer?
This is like take it into and then subtract that to 180.
Okay, so if there's a second answer, it's 154.623.
That's too high.
It's too big,
It's too
okay, because the angle that they gave me was 30. If I try to use the angle that I just found, plus the one that was given, it's too big. So this time, you don't have to worry about a second answer for alpha, gamma, or C. Okay, so now that I have alpha, what can I find next? Gamma. And how do we get gamma?
Add 25 and do 7, 7, and 30, and then subtract that number.
Yep, let's add those up. Subtract from 180. And we get 124.623. And now I can finally finish it off and find C. How would my law of sines be set up to find C?
Sine 30 over 7.
Yep, definitely going to start with that.
And sine 124.623 over gamma.
same thing we did last time, cross multiply. We get c equals 7 times the sine of 124.623 divided by sine 30. Now just type all that in, and that is your answer for C. Any questions on how to type that in?
You just type it in.
Just to see what it. So you should get 7 sine 124.623. That's the numerator. And you divide by sine of 30, which is actually a half. So dividing by half, it's going to double that answer. So 11.521. Okay, always check to make sure the biggest side is across from the biggest angle, and smallest side is with the smallest angle. And any two sides added together should always be bigger than the third. Okay, and that's a law of science problem. So the last 3 questions on the test will be those type. Okay, I'll give you one of the type we just did, and then one angle side, and one angle side angle. The other 2 aren't as tricky because you don't have to worry about the 2 solutions. Okay, so any other questions? Okay.